space, so 100 kilometers, or about 66,000 feet or something. And our focus on doing so is we're going to do it using commercial off-the-shelf parts. So it minimizes our work in doing research motors, researching different control systems. So try to leverage larger rocket motors that are available to the industry, like for use in missiles currently or something. And eventually our end goal is to provide a low access or low cost access to space for education students, which is what Anand will talk about.
Thanks a lot. Yeah. You guys know every university has their own satellite lab, satellite projects, and everybody has a lot of facility dedicated to that. But a probe, unless and until a thing launched into space, orbiting, it's not called satellite, though you're working in so crazy idea. So we want you to believe in, like, we want to launch for students. There are so many people around there charging $1 million, 6 months wait time and all. You want to wait for ISS and other space facilities. But we want to build a launch vehicle which is as low as between $15,000 to $20,000. We want to launch it for you guys, and it will be sole control to you, and we will launch and hand over to you guys. You can do all sorts of experiments. Initially, we are starting with nanosats, CubeSats, and for low Earth orbit, we are aiming as per requirements. We want to get confident in orbits as low as 150 kilometers, and as per the CubeSats requirement, we'll build up. But the basic idea is launch for students, launch for the satellites lab. Don't wait for them, and actually let them call the project as satellites.
Oh, by the way, how much is a CubeSat launch right now? Well, the general going rate, if you want to just buy a CubeSat launch on a berth to piggyback, where you don't get to pick your orbits, you don't get to pick how high, the inclination, whatever, you're just piggybacking on like a main payload, that's still like $100,000 or a few $100,000. So getting it down to 20,000, 15, 10, maybe a few thousands for the students, that's definitely in the range for high school students, easily the range for college students to design and build a CubeSat and set it up either on a suborbital flight or low Earth orbit.
Yeah, we're not like just promising something. Just promising something, another cheap access to space. We want to do it for students, and they have control. Not you're launching with piggybacking 10 satellites around them, and you're just, okay, this is different sat, you just have access to your data, not your spacecraft. So just for students, and with really cheap access. Thanks.
Next up, we have Matt and University High-Powered Rocketry. Here you go.
Hello, everybody. I'm from the University at Buffalo High-Powered Rocketry, part of SEDS. Mainly, we just do high-power rocketry. We do the competition for SEDS here, and we have everyone build and fly rockets. We design it. We fly it level 1s and 2s. And my main goal for this is to be able to build research motors, with the main component being ammonium perchloride, and be able to be cost effective, because a big size motor can range from a couple $100s to thousands of dollars, where if you make it yourself, you can make it for $15 or less. So one of my main goals is to be able to become cost effective, let the students fly really whenever they want, because being a low budget club, I'm sure you all know you can't just buy all the resources you want. Buy 20 motors for $500 a piece, you can't do that. But if you can make them for $15 a piece, I am more than happy to let people fly. So I wasn't really expecting to come and talk. They kind of just recruited me. But maybe just becoming cost effective, and then within the next couple of years becoming hybrid, being able to do liquid propellant and solid propellant, and we'll see where we go from there. Thank you.
Anybody else? Looks like we have some people arriving. You guys that are just arriving, we had a talk canceled, so we're just doing some fast pitch. If you have a project, come up and talk about it for 3 to 5 minutes. What's your name? Brian? What's your project? So, Brian? So we have Brian up with Chimera Space. Here you go, Brian.
Thanks. So I didn't have anything planned, obviously, because this is kind of on the spot. But I want to talk real quick about a company that some colleagues and I started called Chimera Space Technologies, and we're an educational nonprofit. And basically, our goal is to use high-altitude ballooning and high-powered rocketry as media to promote STEM education for K through 12 and even college level. So basically, we see a problem, and that problem is there's a decrease in government funding for these types of projects. Recently, the USLI competition's been canceled, and this comes at a time where STEM education is really suffering in the United States, and we're falling behind. So what we want to do is, so what a lot of people have been doing is developing the next generation science standards, which I'm not sure if a lot of you have heard about, but basically it's new standards for K through 12 education based on giving more hands-on engaging experiences for their students. However, not a lot of the teachers are given the resources to do this on their own. And learning aerospace technologies, it might be easy if we have a group or a club at a university doing high-altitude ballooning or high-powered rocketry that have budgets. But these teachers have full-time jobs, and they have classes full of students and lesson plans to deliver. So that's what our product is full service for graduate-level research in high-altitude ballooning and high-powered rocketry, and taking those services to the students and to the teachers and teaching them how to use these technologies in their classroom. Tell you more about it if you guys are interested. Let me know. Thanks.
Talk very briefly about our Mars Track project. Give me 1 second to get it set up. So Todd Gilbert, one of the organizers, he was the MC for Bill Nye the other night. He and I and several other students here at SEDS-ASU are working on Mars Track. So what we're doing is taking the Global Village construction set. This is a open source project to build the 50 tools that you need for industrial civilization. Everything from tractors to steel rolling devices and stuff like that. They're one of their first projects that they have finished as a tractor. And so we are taking, it's OSE's LifeTrack 6, and we're modifying it for use a really simple cross-piece tied together construction. Just basic tubes, tube with holes. It's this kind of structure. And eventually it would be, 3D printable and or CNCable. Very simple, easy to repair. Think of it as a prototype for a construction rover. Obviously, you could attach scientific instruments to it as well, but we're looking at it more for digging, trenching, filling bags, covering things, regolith processing, things like that. This is that would be the LifeTrack 6, because it's got the articulated piece to it. You can see right there is a joint, flexes. The idea specifically with the open source ecology is to help create permaculture here, so that whatever happens, people will be able to generate electricity, filter their water, and live relatively healthy, comfortable lives. We're hoping to take some of that technology and that approach and push that eventually into space. We're looking at going from the rubber wheels over to kind of lunar rover style metal wheels, or like Curiosity. This is one of our teams. You'll see some familiar faces up there, the Lunabotics team. Long term, eventually convert it over and make it so it's space rated. Drop 100 of them on Mars. Right now, we're looking for crowdfunding, donations, grants, and people either who already have skills or people who want to have skills. If you don't know how to weld and you want to learn how to weld, come work on this with us. And hopefully next year, because we're not going to have it built, we'll have it done for Mars Desert Research Station next field season. So that's the Mars Track project. Got about 5 more minutes before Sarah goes on. Does anybody else have a project they want to talk about real quickly? Okay, we'll resume in a couple of minutes then. Thank you.